Now, today I will discuss solve quantum mechanical problems using Scilab programming. Uh, you already know the Scilab from your third semester course. Using that concept, I will solve the quantum mechanical problems and different types of problems I will solve using Scilab programming. Now, we know from our quantum mechanics, since we are interested with the quantum mechanical problems, therefore, here we have to apply the laws of quantum mechanics. The basic laws of quantum mechanics is the Schrodinger equation. We know from our quantum mechanical classes that if the potential V is independent of time, then we apply time independent Schrodinger equation TISE to find the eigenvalue and eigenfunctions of the stationary states. Okay. Now, in 3 dimensions, the fundamental equation of quantum mechanics is the Schrodinger equation. In 3 dimensions, therefore, we are interested with the time independent Schrodinger equation. Now, in 3 dimensions, the time independent Schrodinger equation is minus h cut square by 2m Laplacian psi plus v psi is equal to e psi, where m is the mass of the particle and h cut is equal to h by 2 pi is the reduced Planck constant. And psi is the wave function, basically time independent part of the wave function. It is better to tell function. Just I am telling wave function, and V is the potential of the problem. Potential under which the particle M is moving, and E is the total energy of the particle. Therefore, in 3 dimensions, the time independent Schrodinger equation is minus h cut square by 2m Laplacian psi plus v psi equal to E psi. If the potential V and the boundary conditions related to a problem possess spherical symmetry, then we use spherical polar coordinates. Spherical polar coordinates is r theta phi. You know Cartesian coordinate is x, y, z. Cylindrical coordinates is rho, theta, rho, phi and z. In spherical polar coordinate r theta phi, that is the wave function is the function of r theta phi, and we have to express the Laplacian operator. This is called the Laplacian operator. Okay, this Laplacian operator in spherical polar coordinates. Now, in spherical polar coordinates, the Laplacian operator is this one. Okay, 1 over r square del r square del psi by del r plus 1 over r square sin theta del theta sin theta del psi by del theta plus 1 over r square sin square theta del 2 psi del pi square. Now you see r has the dimension of length, theta has the dimension of angle, theta varies from 0 to pi. Phi is called the azimuthal angle, it varies from 0 to 2 pi, and r can vary from 0 to infinity. But in our quantum mechanical problem, we are basically interested. Quantum mechanics is the mechanics of subatomic particle. You know that radius of an atom is of the order of 10 to the power minus 10 meter. Therefore, this for the quantum mechanical problem, atomic problem, this r is of the order of 10 to the power minus 10 or less. Okay. Therefore, this. Now, if the above Schrodinger equation, this one time independent Schrodinger equation has different, the above Schrodinger equation has different types of, this equation has infinite number of solutions, but we are interested with a particular type of solution. That type of solution is called stationary type of solution. This stationary type of solution we are interested, because why stationary? Because we are using time independent Schrodinger equation, time independent. Therefore, in this equation, psi is independent of time, v is independent of time, everything. No time appear in this equation. That's why we are interested with the stationary type of solution. Now see the time independent Schrodinger equation in spherical polar coordinates is this one. If you use the Laplacian operator in spherical polar coordinates r theta phi in terms of r theta phi, then this equation becomes this one. This is the Laplacian operator, and v psi is equal to e psi. Now, stationary solution, I already told, we are interested with the stationary type of solution. The stationary type of solution can be obtained by the variable separation method, because here psi depends on r theta phi. I will separate the variables from each other. For that, we write that we are seeking this type of solution. This is the radial part, because it involves only the radius, and this is the spherical harmonics. It depends on your theta and phi, not r theta. It depends on theta and phi. Therefore, this is the angular part and this is the radial part, because we are considering that V possesses your potential and the boundary conditions possess the spherical symmetry. That's why we are using the spherical polar coordinates. And therefore, variable separation method, this is the depending on r and this is depending on theta phi. If you substitute this psi in this equation number 2, then you will get, and after algebra, the radial equation will be this equation, ddr of r square dr by r, because r is a function of smaller, 2m r square by h square v minus e into r is equal to l into l plus 1 into r. Therefore, this equation 3 can be simplified. Now here you see the r is coming. This equation is not so much attractive. To make it attractive, first of all, I will substitute u r is equal to r into r. If you substitute this, then you will get, after algebra, you will get this equation. This equation is very much simplified. Okay, and this equation is now here that L here you see no L. But this L comes during the variable separation method. When you will solve, L is a constant. Actually, L is a quantum number. Its significance is a quantum number. It is the there are 4 quantum numbers. One is the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Here L, the physical significance because is L is a azimuthal quantum number. The value is 0 to n minus 1. Okay. Therefore, if L is equal to 0, then you know in chemistry there are S cell, P cell, D cell, etc. This L is equal to 0 means S cell. Okay, that is the spherical. It has the spherical symmetry, because P has the dumbbell type. P has the dumbbell type shape. That is L is equal to 1. But L is equal to 0 has the spherical symmetry. This L is equal to 0. This S wave means L is equal to 0. Therefore, for L is equal to 0, the radial part becomes d2u dr square equal to 2m by h cut square v minus e u r. Therefore, it is very simplified. It is looking very attractive because you know, if you compare with the one-dimensional time-independent Schrodinger equation in your quantum mechanics you done, d2 psi dx square is equal to 2m by h cut square v minus e into psi. These two equations looks very much same. Okay, only here are there is x. Only this difference. Otherwise, no problem. Same. Therefore, I will use this equation is called the radial solution of Schrodinger equation. Fine. I will use this one. As per your syllabus, whatever problem you will do in quantum mechanics by Scilab, every time you have to use this equation. Okay, because S wave, for S wave L is equal to 0 and the equation, radial equation becomes this one. Now here you see, before applying this equation, you have to careful with the unit of different parameter. First of all, quantum mechanics is a mechanics within the atom or within the nucleus. Now you know the radius of the nucleus is 10 to the power minus 10 meter or 1 angstrom, and radius of the nucleus is 10 to the power minus 14 meter or 0.1 or 10 femtometer. Okay, 10 femtometer. Fine. Now, therefore, but here M is the, if you consider the hydrogen atom, then M is the mass of the electron, R is the stationary orbit, radius of the distance of the stationary orbit from the nucleus. Basically, M is the reduced mass of the electron. Therefore, you have to change, and H cut, you know H cut is equal to H is equal to 6.66 into 10 to the power minus 34 joule second. But here joule is very large unit. That's why in atom or in atomic case, the energy unit is the electron volt. Okay, therefore I have to change R in the angstrom, H in electron volt, mass in SI system it is kg, but you have kg is very large unit. That's why in quantum level M should be expressed in terms of electron volt. Okay, and V is the electron volt and this. Now, therefore you see the d2u dr square, this is the radial equation I will use to solve the quantum mechanical problem using Scilab. This is our fundamental equation. The different potential, different type of solution, different type of problem. Okay, and E is the total energy. Our problem, whenever they will ask you solve this equation. Solve this equation means you have to, V will be given, M, H cut, everything given. You have to calculate this value. E is the eigenvalue, and you have to calculate U. u is called the eigenfunction. Therefore, solving this equation means find out the eigenvalue and the corresponding eigenfunction. That's all. Now, here the problem is that in SI system and our quantum system means subatomic system, either atomic level or nucleus, subatomic system. Now, in SI system, you see length is measured in meter, centimeter, millimeter, whatever. Energy in joule, in length in meter, energy in joule. Electric charge is in coulomb and mass in kg. But in the subatomic system, quantum level, length is measured in angstrom. If it is atomic size, it is angstrom. If it is nuclear size, it is femtometer. Where 1 angstrom is equal to 10 to the power minus 10 meter, 1 femtometer is equal to 10 to the power minus 50 meter. Energy unit is electron volt. If it is atomic level, you know the ground state energy of hydrogen atom is minus 13.6 electron volt. Therefore, electron volt means atomic, mega electron volt means nuclear. Now, the question is what should be the unit of, if length is measured in angstrom, energy is measured in electron volt, then what will be the unit of electric charge and mass? I will show you. In SI system, we know electronic charge is 1.6 into 10 to the power minus 19 and mass of electron is 9.1 into 10 to the power minus 31 kg. Therefore, these are the SI system. Now, I will show you in our atomic system, subatomic level, E will be 3.97 electron volt angstrom. Therefore, charge is measured in electron volt angstrom and mass is measured in electron volt by c square. C is the velocity of light. This one I will show. Now, how I got this value? Next, I will show. Therefore, this is our mother equation. Fine. I will do the programming with the help of this equation. Before using this equation, I have to convert the energy. All energy must be converted. All energy must be converted in electron volt. Okay, and mass must be converted in electron volt. Okay, and your charge also have to be converted in electron volt. Okay, and radius is taken in angstrom. Right, and another is appearing H, reduced Planck constant. It is appearing. In reduced Planck constant, standard value is 6.66 10 to the power minus 34 joule second. Therefore, that joule have to be converted into electron volt. Therefore, H card have to be converted in electron volt. Okay. First, I will do this one. Convert charge in electron volt unit. E is equal to 1.6 into 10 to the power minus 19 coulomb. Okay. Therefore, this equal to, second is charge unit. What will be the charge unit? Charge unit, from the potential energy expression, we know V is equal to E square by R. Now, if V is taken in electron volt, I already told energy must be taken in electron volt. Therefore, this is the potential energy. Therefore, it must be in electron volt. Okay. Therefore, if it is this electron volt and R is in angstrom unit, therefore E square by R means angstrom. Therefore, electric charge unit will be electron volt angstrom. Therefore, my question is, what is this one? What will be the value of this? Charge, express charge in electron volt. In coulomb, this value. In electron volt angstrom, what is the value? This you have to calculate. Okay. Now, therefore, I want to find before going to this value, I want to find a relation between 1 coulomb is equal to how much electron volt angstrom. Then if you know 1 coulomb is equal to this angstrom, then 1.6 into 10 to the power minus 19 coulomb is equal to this into this. Okay, this expression for the potential energy. Series system. In series system, energy unit what? In series system, energy unit is arc. Okay, energy unit is arc. Fine. Energy unit is arc, and in series system, electric charge is in ESU. Therefore, ESU square by R is in centimeter. Fine. Therefore, if what is the meaning? If there are two charges, each of one electrostatic unit, okay, each of one electrostatic unit separated by 1 centimeter, then what will be? Here 1 square means 1. Here it is 1. Therefore, V will be 1 arc. Right? Clear? Now you see, already I told ESU, you have to go to the coulomb. I want the relation between coulomb. 1 coulomb is equal to how much electron volt angstrom. Therefore, use it in coulomb. I already told the 1 ESU is equal to 1 by 3 into 10 to the power minus 9. This is equal to 1 by 3 into 10 to the power minus 9 coulomb whole square by. Now, centimeter must be using angstrom. Therefore, 1 angstrom is equal to 10 to the power minus 8 centimeter. Therefore, 1 centimeter is equal to 10 to the power 8 angstrom. Okay? 10 to the power 8 angstrom. Done? Next, it is arc. Now, here it is arc. You have to go to the electron volt. Therefore, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay? Right? Now, here it is joule, but here it is arc. Therefore, first convert it in joule. We know 1 arc is equal to 10 to the power minus 7 joule. Right? Therefore, put it here. It is 1 arc. Therefore, 10 to the power minus 7 joule. Right? But still is there. You have to go to the electron volt. Now, 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Therefore, 10 to the power minus 17 joule is equal to 10 to the power minus 7 divided by this. Okay? Therefore, divided by 1.6 into 10 to the power minus 19 electron volt. Done? 1 by 9. 10 to the power minus 9 square is 10 to the power minus 18. Coulomb square means Coulomb square. Equal to. Here 10 to the power 8 into 10 to the power minus 7 means 10. Here angstrom, here electron volt. That is 10 electron volt angstrom by 1.6 into 10 to the power minus 19. By 1.6 into 10 to the power minus 19. Therefore 1 coulomb is equal to a coulomb square. Now take it on this side. Coulomb square is equal to 10 into 9 by, here it will go down, therefore 10 to the power minus 18, 10 to the power minus 19, that means 10 to the power minus 37. 1.6 into 10 to the power minus 37 unit is electron volt angstrom by 1.6 into 10 to the power 38 electron volt angstrom coulomb. Therefore 1 coulomb is equal to square root of 9 by 1.6 into 10 to the power 38. Now it will go square electron volt angstrom. Therefore this is 2.371 into 10 to the power 19 electron volt. This express the electronic charge in electron volt angstrom. Therefore 1 coulomb is equal to this electron volt. Therefore this coulomb is equal to, therefore E is equal to 1.6 into 10 to the power minus 19 into 1 coulomb. 1 coulomb means this into 9 by 1.6 square root into 10 to the power 19 electron volt angstrom. Root over 1.6 into 9 electron volt angstrom. Therefore this is 3.795 electron volt angstrom square. This charge I will use in this equation. Next, mass. I have to express the mass from special theory of relativity. We know mass is nothing but energy. Therefore I have to express the mass in electron volt unit. We know E is equal to here. Therefore this is the mass of the electron. We know mass of the electron is m is equal to 9.1 into 10 to the power minus 31 kg. Therefore here is unit is kg, but you have to go electron volt. Okay. Therefore we know E is equal to mc square. Therefore you can write m is equal to mc square by c square. You can, therefore if c is in meter per second and m is in kg, then mc square will be in joule. Okay, joule. Then this one is equal to joule by c square. Remember this. Therefore now come to this mass. Electron mass is 9.1 into 10 to the power minus 31 kg. Okay, this is equal to 9.1 into 10 to the power minus 31 c square. Therefore kg into c square is in joule by c square. Here c is equal to 3 into 10 to the power 8. Next, joule must be in, has to be converted in electron volt. We know 1 electron volt is equal to 1.6 into 10 to the power minus 7 and 1.6 into 10 to the power minus 19 joule. Therefore if you convert the joule into electron volt, that will be 9.1 into 10 to the power minus 31 c square by 1.6 into 10 to the power minus 19 electron volt by c square. 9.1 into 10 to the power minus 31 into c is 3 into 10 to the power 8 whole square by 1.6 into 10 to the power minus 19 electron volt by c square. Therefore into 10 to the power 4 electron volt by c square. Now calculate this one. Therefore, this is 51.1 into 10 to the power 4 electron volt by c square. Now, this can be written as 0.511 into 10 to the power 6 electron volt by c square. Therefore, M is equal to 0.511 into 10 to the power 6 electron volt. Therefore, electron volt unit. Fine. Next is charge is done. R is in angstrom. Next is H cut. This value I have to convert. Okay. Now to convert H cut, because C is a universal constant. Next, H cut. We know the standard value of H cut is called reduced Planck constant. The definition is H by 2 pi, where H is called Planck constant. The standard value of H cut is 1.0545 into 10 to the power minus 34 joule second. This is the standard value. Okay. If you search the Google, it will give you this value. Right? Other numbers are there. I am not writing. Okay. Now, here it is joule, but in the subatomic scale, I have to go in electron volt. Therefore, convert this. Since the velocity of light is a universal constant, therefore, instead of H cut, I will find out, because here you see c square. Already you have used the c. Therefore, instead of H cut, here it is H cut square. Therefore, I am using H cut c is equal to how much? I will express that. Now see, Ch cut c is equal to 1.0545 into 10 to the power minus 34 joule second into c. C means 3 into 10 to the power 8 meter by second. Right? Now second cancel out. Therefore, this is equal to 1.0545 into 10 to the power minus into 3 into minus 34 plus 8. How much? Minus 26. Therefore, 10 to the power minus 26 joule meter. Okay. Now convert joule in electron volt. What will you do? Divide by 1.6 into 10 to the power minus 19. Therefore, divide by 1.6 into 10 to the power minus 19. Therefore, this becomes electron volt. Now, next meter. Convert the meter into angstrom. We know 1 angstrom is equal to 10 to the power minus 10 meter. Therefore, 1 meter is equal to 10 to the power 10 angstrom. Therefore, here into 10 to the power 10 electron volt angstrom. This is equal to 1.973 into 10 to the power 3 electron volt angstrom. This is equal to, now 10 to the power 3 যদি multiply করতে হয় তাহলে 1973 electron volt angstrom. Therefore, H cut C is equal to 1973 electron volt angstrom. Therefore, everything done. You see, M is in electron volt, H cut is in electron volt, R is in angstrom, R is equal to 10 to the power minus 10 in angstrom. R is in angstrom. 1 angstrom is equal to 10 to the minus 10 meter. Fine. R is in angstrom. Energy is in electron volt. This one. The problem is, therefore, you have to find E. Okay? You have to find E. Now, if you put this, then this will come in electron volt. Okay? This will come in. Now, in case of hydrogen atom, we know first quantum state is called Bohr orbit, and the radius is called Bohr radius. Now, one Bohr radius is equal to 0.529 angstrom. Therefore, you see, when you are solving the first ground state, therefore the R must be less than this. Okay? R must be less than this. Therefore, take R, suppose 0.01 angstrom or 0.1 angstrom, whatever. Take R. Okay? Less than. You have to start less than this. Then we know that if I multiply by 10, then it will because atomic radius is 1 angstrom. 1 angstrom. Therefore, 0.1 angstrom to 10 angstrom. Take it. Right? Therefore, take the R. When you will do the programming, you have to in this unit. Okay? You can change the R. Now you see, my method is here a solid SOF Schrodinger equation can be solved in different way. As per your syllabus, they are telling that either you can use matrix method or you can use finite difference method or you can use ODE solver method, or I will use the finite difference method. Finite difference. I will follow the finite difference method. Okay? What is finite difference method? I will show. Now, therefore, you see, this is our mother equation. What I have to use in our programming. Okay? This is the SOF Schrodinger equation for the radial part. For L is equal to 0. SOF means L is equal to 0. Now, here in finite difference method, I am dividing this whole length into finite number of points. Okay? Finite number, equidistant. They are equidistant. Suppose distance is d. Okay? Distance is d. Suppose this one is nth point. This is your n plus 1 and this is your n minus 1. Fine? Therefore, this is the grid. You have to generate the grid and this will give the R. Fine? This will give the R. Now, suppose this is the grid. Here I am taking this is the nth point of the grid and this is your n plus 1th point of the grid and this is your n minus 1th point of the grid. Right? Now, the wave function u It is a function of r. The wave function at nth point is un. Wave function at n plus 1th point is un plus 1. Right? And here it is un minus 1. Here? Now, using d to u or dr square. Computer don't know what is d to u dr square. In finite difference method, I have to convert it in this form. I have to convert. Here is the finite difference. You see, finite difference. This is called finite difference. Now, computer don't know this. Therefore, convert this in unit difference method. Okay? Difference. Now you know what is dy by dx. Suppose this is your function x. So you want to calculate the dy by dx at a certain point. What you are doing? What you are doing? You are taking 2 points. You are taking 2 points. This is your y1, this is your y2, this is your x1, this is your x2. Right? Now, what is the dy dx? Definition is what? Dy by dx is equal to limit, suppose x2 minus x1 is equal to h. Okay, limit h tends to 0, right? Limit h tends to 0, y2 minus y1 by x2 minus x1. This is the definition. R square means d to u dr square means ddr of du by dr. Right? Now, come to dy by dr. du by dr. In finite difference method, you can write, suppose this is d. Okay, all are equidistant, right? Therefore, you can write un plus 1 minus un by d. Okay, you can write dy by dx কি করতে y2 minus y1 by h. Okay, here un plus 1 minus un by, this is your 0, suppose n 0. Therefore, this is your plus d, this is your minus d. Right? Therefore, you can write, therefore du, what is du? Du is un plus 1 minus un. That is your du, un plus 1 minus un by dr. Dr means this plus d minus 0 is d. Right? Therefore, d. Again, you can also write on the other side. What? Un minus 1 minus un. Right? Du means un minus 1 minus un by, now, minus d minus 0. That is minus d. Right? Minus d. এটা minus sign যদি এ করে দিও un, মাইনাস চিহ্ন যদি এটি অ্যাবজর্ব করে দিও তাহলে কি হবে না un minus un minus 1. This is your du by dr in finite difference method. Next, d to u dr square. Okay, now d to u dr square means ddr. apply DDR. Okay, here it is DUNDR, right? This definition is DUNDR is equal to this one. Fine. Now I am going to D2UN. I am going to D2UN. D2UN dr square is equal to DDR of UN plus 1 minus UN by D. Right? Now, this can be written as DUN plus 1 by DR minus DUN by DR by D. Right? Now, you have DUN DR is equal to UN minus 1 by D. Right? তাহলে দেখো DUN plus 1 by DR কি হবে? এটি যদি n plus 1 বসাও তাহলে এটি বি n plus 1, এটি n plus 1 minus 1, তার মানে n this one. তাহলে কি হবে? DUN DR is equal to UN plus 1 minus UN by D. Next, DUN DR. DUN DR is equal to this. Therefore, write minus UN minus 1 by D divided by D. এটা D2N dx by this is your D2UN d r square, right? Therefore D is common, D will go down, therefore D square. Next is UN plus 1 minus UN plus UN minus 1. Therefore, this is equal to UN plus 1 minus 2UN plus UN minus 1 divided by DRD on a D square. This one. This is your D2UN dr square. Here you can write n infinite difference method n n. That's all. Therefore, n is equal to 1, it will be ground state. N is equal to 2, first excited, the values you have to calculate. Okay. Therefore, now put this expression in Schrodinger equation. Substituting this in the Schrodinger equation, we get minus h cut square by 12 UN plus 1 plus UN minus 1 minus 2UN by D square. Okay. Next, plus V into UN equal to EN into UN. This is the equation. Okay. Therefore, this is the, now see, it was continuous, but here because here dr, I mean very small. Okay. That's why, but I am converting into finite difference method with d of the order of angstrom. Right? D of the order of angstrom. Everything right. N is equal to 1, 2, 3, infinity. Okay, infinite. Now, for n is equal to 1, what is this? Now, expression is minus h cut square by 2m d square into n is equal to 1. তাহলে 1 plus 1 2 u2 n minus 1 1 minus 1 0 plus u0 and here minus 2 u1 plus v of n because v is depending on r. Here I am replacing r by n. Here you see no r. Why? Because discrete. I am taking the discrete point. R is equal for n is equal to 2. Tell me. What will you write? u3 2md square. u3 plus u1 minus 2u2 plus v. अच्छा, it n is equal to 1. Therefore, this is 1. Okay. v2 this is 1. u1 is equal to u2 is equal to e into u2. Okay, done. Next, n is equal to 3 minus h cut square by 2md square. 3 means u4 plus u2 minus 2u3 plus v3 into u3 is equal to e into u3. Okay, n is equal to n what minus h cut square by 2md square into un plus 1 plus un minus 1 minus 2un plus vn into un equal to e n into un. Fine. Here you see n is varying from 1 2 3 etc. Therefore our wave function u1 u2 dot 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 un. This is your u is in discrete form, right? Here you see no u0, but here you see u0 is coming. Okay, therefore this must be 0. Take. Okay, u0. Next is here up to un minus 1 un, no un plus 1. Therefore take this 0. Okay, this one. Now I will write this set of equation in matrix form. How can you write? You see, in the matrix form. You see, minus h cut square by 2m d square. This I have to write. This is the kinetic energy term. This into u1 u2 dot 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 un plus here it is the v, take it v. Okay, I am taking instead of just I am writing v. Okay, because v depends on r. In the expression I will give. Okay, in the expression take it v and take it e is equal to E into U1 U2 dot 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 Un. Fine. Now see what will be here and what is the V. V is a matrix here. Okay, right? Now what can I write? You see here U2 here is এটা হচ্ছে U1 or column, U2 or column, U3 dot 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 Un. Fine. Now here you see U2 each coefficient is 1. Therefore here you see U2 each 1 coefficient is 1 and U1 coefficient is -2. Therefore you can write -2 1 0 0 0 0 dot 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 0. You see -2 into U1 plus U2, U0 is 0 into minus a square by 2md square plus V into U1 is equal to E into U1. Right? Next this one is U3 is 1. What is U3? Here it is U3 is 1. Here U2 is -2. This is -2 and U1 is 1. Right? 0 0 0 dot 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 0. Fine. Next V into U2, that I will show you. Here it is the matrix. When I will write the matrix, then it will be clear. Okay. Next, let me first concentrate on this matrix. Next, U4 is 1. Here it is U4. Then U3 is -2. This is your -2. Then this is your U2 is 1. U2 is 1. U1 is 0. 0 0 0 0. Right? Next, N. You see, in case of N, here it is the UN. UN plus 1 is 0. UN -2. Therefore, here -2. And UN minus 1 is 1. Here 1. Rest is 0. Right? Therefore, you see, this is the diagonal. This is the diagonal. And this is the lower diagonal. All are 1. And this is the upper diagonal. Fine? If you write properly, then you will be clear. Here I am not written properly, that's why it is bending. But if you write properly, then you will see the diagonal. This is the main diagonal. In the main diagonal, all are -2. In the lower diagonal, all are 1. And in the upper diagonal, all are 1. Fine? Next, here V. It is a matrix. This can be written as V 0 0 0 dot 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 0 0 V 0 0 0 V 0 0 0 0 V into U1 U2 dot 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 UN equal to this. Therefore, you see, V into U1, then V into U2, V into U3, like this. Fine? Mind it, V is depending on R, means A. right? Therefore, take this is kinetic energy. This part, this is take kinetic energy, and this take potential energy, and this take total energy. Here it will be like this. Here it can be written. Okay, it can be written. Now, therefore, this is your K means with this. This is your K. Therefore, you can write K into U, capital U. Capital U means it is a column vector. U1, U2, U3, Un, right? Plus this is the potential energy V into capital U is equal to, this is called Hamiltonian, because if you common this K plus V is called the Hamiltonian. Okay, right? This is equal to E into E. Now, therefore, this is a matrix. A K H is a matrix. Okay. Now, how can you? Therefore, in the programming, first I have to choose a grid. Okay, I have to choose a grid. Second, I have to construct the Hamiltonian matrix. Okay. Once you got the Hamiltonian matrix, use this command in Scilab, spec of the matrix. This command will give you eigenfunction and eigenvalue. That is your requirement. Solve means find the eigenvalue, find the eigenfunction. They will give set of eigenvalue. Your ground state will be n equal to 1. Okay. Next excited, first excited state n is equal to 2. Therefore, you can from the computer will give you. Okay, and it will also give the eigenfunction corresponding. Eigenfunction it will give. Okay. To write the script file, you have to use the editor. That editor is called Scilab. Either you can write in the console Scilab, then file name, or there is an icon on the left hand side. If you open the Scilab software, then you will see a window will come. A window will come. Here a icon is there. If you bring the cursor here, it will show you Scilab. Just click it. Okay. Then the Scilab editor will come. Scilab editor will come. Now you have to write the program. Okay. Now